Alright, so problem number 7 says the crate below is to be constructed using 24 feet of lumber. What is the equation that represents the volume of the crate as a function of x? And then secondarily, sketch a graph of the function. So there are a couple things to consider here. The first, of course, is that I know I have 24 feet of lumber, and I want to represent the volume of the crate as a function of x. So when I think about what that's asking me, that means I need a function for volume, and the independent variable needs to be x, needs to be in terms of x. Well, what's the volume of a crate? If I look carefully, right, I can realize that it's going to be length times width times height. And I can simplify that further because it gives me variable names for each. So if I take a look, I notice that the length is x and the height is x, and the width is y. What does that mean? Well, it means the length and the height are the same. So I can continue on. The length is x. The height is x. I'll just rearrange it so it's x times x. And the width is y. So what does that give me? Well, it gives me x squared times y. And so I'm close. Remember, I want to find, when I was understanding this, I wanted to find what is the volume in terms of x, as a function of x. I have y, I just need to find y in terms of x. And so we need some other piece of information. So remember that we know we have 24 feet of lumber. Well, look at the construction of the crate. That means that all of my sides added up need to equal 24. So I know that 24 is going to equal, well, what makes up all those sides? I have 8 x's plus 4 y's. And if you are struggling to figure out why that is, pause the video right now and just try and figure out for yourself, how would I add up all the sides? What would they be? Alright, so I need to figure out how to manipulate this this new function that I have, this new equation that I have. What I want you to do right now is pause, think about what you need to find, and then how could you find it, try and find it, and then press play again. Alright, so hopefully you realized we want to isolate y. We want to find y in terms of x. Alright, so we're going to solve for y, and we're going to end up getting 24 minus 8x divided by 4. Okay. And so now using this, I can finally find my volume equation. What I want you to do is pause again, try and find the volume equation yourself, and then check back to see if you've gotten it correct. So hopefully you realize, look, I know what y is in terms of x, so I can plug this in for y and have volume in terms of x only. So to do that, I will get volume equals x squared times 24 minus 8x over 4. And I'm going to do a little simplification. I'll get x squared, and in the parentheses, 24 divided by 4 is 6, and 8x divided by 4 is 2x. So that's my equation. And if you notice, what type of an equation is this? I want you to just stop for a second, take a look at it, and think about what kind of equation this is. Hopefully you realize this is going to be a third-degree polynomial. X squared times a function or a factor with x is going to give me a cubic polynomial. So this should have 3 roots. So if I want to sketch a graph of this function, this is the volume and this is the length of side x, well, I know the basic shape, right? At least I should. Now it's important to note here that if I were to multiply this out, I would get negative 2x cubed plus 6x squared. So here, the negative out front means that instead of my function looking like that, it's going to look like this. Okay, so I know that one of the zeros occurs when x is 0. That's given by the x squared term, and that's a double root. It's a root of multiplicity 2, which means that it will bounce off. So it's going to come down, it's going to hit at 0, and it's going to bounce back up. And then it's also going to have a root when this factor is 0, which is given when x equals 3, because 6 minus 2 times 3 is 0. And that's the root of multiplicity 1, so it's going to come back down through 3 and continue downward. And that's what my function is going to look like. And so you might guess that the maximum volume of the box is going to occur maybe somewhere around 1.5. I'm not sure exactly what it is, but you could find it. And that's the value of x that will give it the greatest volume. So then you, of course, could plug in 1.5 for x. You could find the y value and find the dimensions of your box. But what we're really concerned about is, can we sketch a graph and use that to help us decide, where the volume of the box, for example, will be positive. So it's important to note that if I have a negative x value, that's just impossible. I can't have a side with negative length. So I'm really only concerned about the values between 0 and 3, because those are the only values that make sense and that also give me a positive volume. Anything past 3 is going to give me a negative volume, which of course isn't going to work out for me. And a good exercise would be to think about what happens if x is 4. In fact, I think that'd be a really smart idea right now for someone who's really trying to understand this problem. If x is 4, what would happen to the box? Go ahead and pause the video, think about it, and we'll come back. So if x is 4, imagine this is 4 and this is 4. What will that do to the other parts of the box? Well, remember how y is 24 minus 8x divided by 4? What if you plugged in 4? You get 24 minus 8 times 4, which is 32. That's going to be a negative number, negative 8 to be exact. And negative 8 divided by 4 is going to be negative 2. Well, can you have a side of length negative 2? We already discussed that. So clearly, when I go above 3 in the x value, that makes my y value a nonsensical number.